Here we are solving January 2024 Pure Math 4 paper. In part 1 and 2 of this video, we covered question number 1 to 6. Now let's move on to question number 7. This is clearly a substitution method. Sorry, I was about to say integration by parts because I did not see that clearly. When you have e power x and cos trigonometric function, it's integration by parts. So it's clearly a substitution method. They want you to substitute u is equal to this, the thing as in here as a power of e, or otherwise show that. Okay, let's go for substitution method. So we have to carefully convert everything in terms of u. So we can straight away, we need to convert the limits also. We can straight away write e power u. And how about cos square? We have 4x plus 2 sine 2x is u is equal to this. We need to find cos 2x here, cos square here. So what we can do, probably we can differentiate this. Let's try to find dx. So du over dx is 4x becomes 4. This becomes 2 times 2 cos 2x. If you take 4 outside, you'll get 1 plus cos 2x. We know this double angle formula. Cos 2x is 2 cos square x minus 1. If you rearrange, you'll get 2 cos square x is 1 plus cos 2x. So we can replace 1 plus cos 2x by 2 cos square x. Why I'm doing that? Because we have cos square dx here. So we will have du over dx is equal to 4 times 2 cos square dx. But we need cos square dx, cos square x dx. So we will get du over 8 is equal to cos square x dx. So we can replace this by du over 8. Now we need to convert the limits now. We have x and u is equal to 4x plus 2 sine 2x. When you replace x by 0, the u becomes sine 0, 0, 4, 0. So everything is 0. When you replace x by the upper limit pi over 2, 4 times pi over 2 is 2 pi. And then sine 2 times pi over 2 is sine pi is 0. So you'll get just 2 pi. So the limit will be 0 to 2 pi. So that's all. We have converted everything in terms of u. So when you integrate this, you can keep 1 over 8 outside. Integral of e power u is the same, 0 to 2 pi. Sub in the upper limit minus lower limit, you got the answer already. When you sub in upper limit, it's e power 2 1. When you sub in lower limit, e power 0, anything power 0 is 1. You will get e power 2 pi minus 1. That's all. Part B of the question, we have a figure given with the shaded region 0 to pi over 2 is the limit. The curve given shown in figure 3 has equation this. Okay. The region R shown shaded in figure 3 is bounded by positive x-axis, the positive y-axis and the curve. The region R is rotated 2 pi radians about x-axis. Find the volume. The formula to find the volume is pi integral y square dx. In this case, the limit is 0 to pi over 2. If you look at the figure, the limit is 0 to pi over 2. Okay. Y square, v is equal to, when you square y, 6 square pi integral 0 to pi over 2. 6 square becomes 36. E power something whole square is, you can just multiply the power. So it becomes e power 4x 2 sine 2x. Multiply everything by 2. Cos becomes cos square x dx. This question has only 3 marks because we are going to use the result from part A here. We calculated this actually in part A. Let's look at part A. Here you can see integral 0 to pi over 2 e power this cos square can be replaced by 1 over 8 e power 2 pi minus 1. In this case, it's going to be 36 over 8. 36 over 8 e power 2 pi minus 1. Simplify 36 over 8. You'll get 9 fours are 36. 2 4s are 8. 9 over 2 e power 2 pi minus 1. That's all. That's why the question got only 3 marks. Question number 8 now, from prove by contradiction. Use prove by contradiction to prove that the curve with the equation y equals 2x plus x cubed plus cos x has no stationary point. You can write the assumption first. We always take the assumption as the opposite of the statement we are trying to prove. So y is equal to 2x plus x cubed plus cos x has at least a stationary point. That's the assumption. And now we are going to try to prove the assumption. When we try to prove the assumption, we are going to end up with a step which is going to contradict the assumption. That's how the prove by contradiction works. So if the assumption says this function has at least one stationary point, when you put dy by dx is equal to 0, you get the x coordinate of the point. When you differentiate it, 2x becomes 2, 3x cubed becomes 3x square, cos x becomes minus sin x is equal to 0. So you will get 2 plus 3x square is equal to sin x. The range of sin x, if you look at the graph, it's 1 to minus 1 to 1. But if you sub in any real number here, the value of this will always be 2 or more than 2. If you sub in x is 0, it will be 2. If you sub in any other number, it will be more than 2. So sin x and this function will have no point of intersection. Otherwise you can do this actually. Take 3x square, 2 plus 3x square will be somewhere here, intersecting at 2. That would be 2 plus 3x. So no point of intersection between these two graphs. So what are we going to write as a conclusive steps? This is what you need to write. You need to write the range of sin x is minus 1 to 1. Therefore, the function has no stationary point. That's not the conclusion actually. That's the opposite of the assumption. So you need to write the 3 usual steps. The assumption is wrong. This contradicts the assumption because the assumption says the function has at least a stationary point, but we have concluded the function has no stationary point. So you need to write first step, these 3 lines you always write for proof by contradiction. First one, this contradicts the assumption. Number 2, the assumption is wrong. Therefore the assumption is wrong. Number 3, therefore you write the original statement. The curve with the equation y is equal to this has no stationary point. Always remember this. If you don't write the conclusive steps, you will lose a mark. So that's all. Question number 9 now. There is a figure given and the parametric equation, parametric functions of the figure is given also. Figure 4 shows a sketch of the curve C with parametric equations. Find dy by dx. To find dy over dx, you need to find dy over dt. That means you need to differentiate this with respect to t and then divide it by dx by dt, differentiate this with respect to t. So first dx by dt, derivative of secant x is secant x tan x, and then dy over dt is, when you differentiate tan x, keep root 3 as it is, differentiate tan x, it becomes secant square t plus pi over 3. It looks like a complex function. It's just a normal one because we are differentiating with respect to t. So you need to basically multiply by the coefficient of t. The coefficient of t is 1. So you don't need to worry about this. The pi over 3, just ignore it. It can be anything. So now we are going to divide both. That's all. So it's going to be root 3 secant square t plus pi over 3 divided by secant t tan t. That's dy by dx in terms of t. Just a 3-mark question. Let's move on to part B now. Find the equation of the tangent where t is equal to pi over 3. To find the equation of the tangent, we need slope and we need a point with x and y coordinate. So when you sub in t is equal to pi over 3 in x and y, you will get the x and y coordinate of the point. So x is secant t. So when you replace t as pi over 3, x is equal to 1 over cos pi over 3. Use radian mode. 1 over cos pi over 3. That's a decimal number, so I'm not going to use that actually. So let's find cos pi over 3 first. Cos pi over 3, and then we put a reciprocal of it. Why I'm getting a decimal? Oh, sorry. Okay, this is a common mistake. You see, my calculator is in degree mode. So I'm going to change it back to radian mode. That's 1 over 2. So 1 over 1 over 2 is going to be just 2. Okay, that's a classic mistake actually. Make sure your calculator is in radian mode. So y is equal to, y is basically this, root 3 tan t plus pi over 3. Root 3 tan, replace t by pi over 3. Pi over 3 plus pi over 3. 2 pi over 3. So it's going to be root 3 times, oh no, I'm afraid I'm going to get a decimal number, tan 2 pi over 3. Okay, good. Negative 3. Y is equal to negative 3. That means we got the x and y coordinate of the point. Now all we need is a slope. We have dy by dx here. In this dy by dx, replace t by pi over 3. How do we write that step? Slope m is equal to dy over dx at t is equal to pi over 3. So you'll get root 3 secant square pi over 3 plus pi over 3. How do we calculate it? Find the value of 1 over cos 2 pi over 3 square divided by secant pi over 3 tan pi over 3. You see how I'm going to do that? First, I'm going to find cos 2 pi over 3. Cos 2 pi over 3. That's negative 1 over 2. So when you square the answer, that's cos square 2 pi over 3. Secant square is 1 over cos square. So it becomes just 4. 4 root 3 divided by, you need to find tan pi over 3, 1 over cos pi over 3. 1 over cos pi over 3 is 2. Actually, basically, secant pi over 3 is 2 times. Now tan pi over 3. Tan pi over 3. Close the bracket, you will get root 3. So you can cancel this, you will get 2. So we have a slope, we have a point. It's easy to find the equation of the tangent in this form. So the equation of the tangent is y minus y1. y1 is the y coordinate of the point, is equal to slope times, slope is 2, yes, x minus the x coordinate of the point. So y plus 3 is 2x minus 4. Y is equal to 2x minus 7. That's the equation of the tangent. That's all. It's a 4-mark question. Part C says, show that all points on C satisfy the equation. When you have a set of parametric equation, and when they say show that all points satisfy this equation, and you see an equation in terms of y and x and y, basically they want you to find the Cartesian equation. That's all. It's a 5-mark question. You need to find the Cartesian equation. You take y, it's given us root 3 tan t plus pi over 3, and this x is given as secant t, 1 over, okay, secant t. Okay, I'm going to apply the angle addition formula for tan of a plus b, which is given in the data booklet. Tan a plus tan b divided by 1 minus tan a times tan b. And then if you find the tan t from here, if you flip both sides, it's not gonna, okay, if you flip both sides, you'll get 1 over x is equal to cos x. That's not gonna work actually. We need to find tan t. So let's use this identity. Secant square minus tan square is 1. So secant square is 1 plus tan square. We need tan square, we need tan t actually. So tan t is secant square minus 1, which is x square minus 1 is tan t, tan square t. So tan t is going to be square root of x square minus 1, and then tan pi over 3. Make sure the calculator is in radian mode. Tan pi over 3 is root 3. So I can write this as tan t can be replaced by square root of x square minus 1 times, plus tan a plus tan b root 3 divided by 1 minus square root of x square minus 1 times square root of root 3. We need to simplify this and write it in this form. Okay, so what I'm going to do now, I'm going to write this as, keep the root 3 as it is, square root of x square minus 1 plus square root of 3 divided by 1 minus root 3 times root x square minus 1. I'm going to multiply and divide by, it's like rationalizing the denominator, We multiply and divide by 1 plus root 3 times x square minus 1. So if you do that carefully, simplify, you will get the answer. So I'm going to take this and multiply both. I keep this root 3 as it is. So I will get root 3 times root x square minus 1. Sorry, when you multiply by 1, you will get just root x square minus 1. And then plus root 3 times, when you multiply this times this, you'll have root 3 as it is, square root of x square minus 1 times square root of x square minus 1, just the x square minus 1 without square root. And then root 3 times 1, and then root 3 times this, so it becomes 3 square root of x square minus 1. Divided by a plus b times a minus b is a square minus b square. This is b. When you square it, it becomes 3 x square minus 1. So I'm going to carefully simplify this. What I'm going to do, these two are like terms. So when you add them, it becomes 4 square root of x square minus 1. So it's gone. Now we are left with these two terms. I'm going to take square root of 3 as a common factor. So I have x square minus 1 in the first term plus 1 in the second term divided by 1 square is 1, open the bracket, minus 3x square plus 3 is equal to, here you can cancel this, you'll get root 3x square plus 4 square root of x square minus 1. Okay, I noticed something when I reached this step. We totally forgot about this root 3 actually. There is a root 3 here. Okay, never mind. I'm going to put the root 3 here. Divided by 4 minus 3x square. So take the root 3 and multiply both. You will get 3x square plus you will get 4 root 3 root of x square minus 1. Since these two got square root, you can multiply them. You will get 4 3x square minus 3 square root of divided by 4 minus 3x square. It looks exactly like this, where a is equal to 3, b is equal to 4. That's all. It's a 5-mark question.